Have you ever looked at a photo, a sign, a poster, and just wished you could change the words? And I'm not talking about some clunky Photoshop job, but a perfect, seamless edit, like it was always meant to be there. Well, today, we're looking at an AI that does exactly that.
So take a look at the sign right here. You can see the text, right? It's got a very specific font, a certain color, a texture, and it's sitting on that brown background with its own unique lighting. Now, what if you had to change Stirling Castle to something totally different, like, say, ancient ruins? How would you even begin to do that?
And I mean perfectly. So perfectly that the new letters have the exact same white color, the same sharp font that gets the same subtle reflection from the sky, and the background behind them is filled in so flawlessly that you'd never know anything was changed. Sounds like science fiction, doesn't it? Well, for a long, long time it was.
The official name for this is Scene Text Editing, or STE. And the key thing to get here is that it's so much more than just swapping out letters in a Word doc. We're talking about digital magic, really, making an edit so clean it's completely and utterly undetectable. And that, it turns out, is an incredibly difficult problem for an AI to solve. You know, to really understand why this new tech is such a big deal, we first need to look back at what came before. Let's dive into why the previous generations of AI just couldn't crack this problem.
Okay, this picture says it all. On the left, you've got the original image, the word hi in this nice, clean, metallic font. But on the right, well, that's what happened when an older AI tried to change it to trees. It's a total mess, right? The style is all warped, the background's got this weird smudge, and the letters themselves are just blurry and distorted. In the past, there were really two main approaches: GAN-based models and diffusion-based models. Now, the GANs, they were often trained on pretty limited data, so if you showed them a new font or a style they'd never seen before, they just couldn't handle it. And the diffusion models, while they're super powerful, they often got the big picture right, but fumbled the details. The letters would be there, but the color, the texture, or the background would just be off. A dead giveaway.
So, you'd end up with this whole catalog of failures. You'd get these messy digital artifacts, styles that didn't match the original text at all, and, get this, sometimes the AI would literally misspell the word you asked it to write. The results were blurry, they were unconvincing, they just weren't good enough. But now, a new model called TextCtrl has completely changed the game. And it's all because it's built on a fundamentally smarter idea.
The creators of TextCtrl really nailed the core problem right here in this quote. They figured out that the old models were failing because they lacked good guidance on two super important things: the text style and the new letter's structure. The AI was trying to figure out both things at the same time, and it was just getting confused.
So TextCtrl's secret sauce, its big aha moment, was to just split the problem in two. First, it focuses only on understanding and deconstructing the style of the original text. We're talking font, color, texture, the whole shebang. Then second, it separately focuses on understanding the exact geometric structure of the new letters it needs to write. By separating those two jobs, it just avoids all that confusion and gets incredible results.
So how does this two-part secret actually work under the hood? Let's break down how TextCtrl works its magic.
All right, this diagram shows you the model's overall architecture. Now, I know it looks a little complex, but the real magic is happening in two key training steps that happen before the AI even starts to edit anything. Okay, the first part is called Style Disentanglement. The best way to think about it is like a master chef tasting a sauce. They can instantly tell you every single ingredient: the salt, the herbs, the acid. TextCtrl is trained to do the exact same thing with an image's style, breaking it down into its core components: the precise color, the specific font, the surface texture, and all that background info. The second part of the puzzle is Glyph Structure representation. Now, a glyph is just a fancy word for the specific shape of a letter. TextCtrl is pre-trained on tons of different fonts, so it knows exactly what an A looks like, or a G, or a W. This is how it avoids all those spelling mistakes and weirdly shaped letters that messed up the older models.
But look, having the right ingredients in the right recipe isn't always enough. A good chef tastes the food as they cook to make sure it's perfect. Well, TextCtrl has a really similar mechanism for making sure the edit is flawless.
It's called Glyph-adaptive mutual self-attention, or GaMuSa. Yeah, it's a bit of a mouthful, but the concept behind it is absolutely brilliant. As it's generating the new text, the AI is constantly looking back at the original text for reference, just like an artist keeps glancing at their subject. This makes sure every single new letter it creates perfectly matches the original style, keeping everything consistent.
So that's the theory.
A smarter approach, separating style from structure, plus a clever self-correction trick. But does it actually work? Well, seeing is believing. Let's look at the results.
Here we go. On the left, you see the original, food. On the right, TextCtrl's edit to good. I mean, just look at that. The background texture, the lighting on the letters, the font, it is absolutely perfect. You can't see any trace of that original F.
And here's another one. Help becomes desk. The blue color is identical. That subtle shine on the letters is perfectly preserved. The edit is completely, totally seamless.
These images are amazing, no doubt. But the most convincing proof is in the hard data. TextCtrl isn't just a little bit better than the older models, it represents a quantum leap forward.
So on a standard test, the second best model, called AnyText, got a word accuracy of about 51%, basically a coin flip on whether it would get the word right. TextCtrl, with its new method, scored almost 85% accuracy. That is a staggering improvement. 84.67%. Just let that number sink in for a second. In AI development, progress is usually slow and steady. A jump this big isn't just an improvement, it's a fundamental breakthrough. It completely redefines what's possible in this field.
And this tech works beautifully in full complex scenes too. Here, a street sign for Queen Street is flawlessly changed to King Street. The new letters match the perspective, the lighting, even the weathering on the sign. It's practically impossible to tell it was ever edited.
This brings us to a final and pretty important thought. TextCtrl is an incredible piece of technology, for sure. But as this kind of power becomes more and more accessible, when the text in any image can be changed this easily and this perfectly, what does that mean for the authenticity of what we see online? It's definitely something to think about.